One of the questions we get asked the most is, why are you doing this the way you're doing it? And to answer that, you really have to understand what general aviation used to be. If you go back to 1978, then the general aviation industry, well, the US manufacturers in the general aviation industry alone were producing 17,811 light single-engine aircraft every year. The business was bigger than the supercar market was at the time. It was thriving. Back then, a Cessna 172 would cost around $80,000 in today's dollars, which was about, in 1970s terms, 1.3 times the average American salary. Today, that same aircraft is 6 times the average American salary, and people in relative terms have never been wealthier. What's happened is that we've now got a general aviation industry that's producing relatively old aeroplanes for far more than they ever used to, and as a consequence the market demand has dwindled. We're just not making the product that people want anymore. General aviation isn't dead, but we've got to do much better as an industry. We've got to design captivating, exciting new products to bring all of those people that never went away back into general aviation, and to make them want to fly again and want to own light aircraft again. We've got to give them the product that they want, a product that's truly of 2025. The idea of personal flight is totally enchanting, you know, being able to travel point to point on your own magic carpet ride in a first-class cabin. Who wouldn't want to do that? But to do that, we've really got to make an aircraft that appeals to today's customer. You know, these people are used to driving the best cars that money can buy, wearing the nicest clothes that money can buy, living in beautiful houses. They have all the latest electronic gadgets and what have you. You've got to live up to those expectations. So we need to make an aircraft that's beautiful, that's fast, powerful, safe, smooth, simple to use, but above all, it has to be affordable. We need to make an affordable Grand Tourer of the sky. And that's really what the requirements were for HX50. Carry 5 95-kilogram passengers, their bags and 3 hours of fuel, fly at 140 knots smoothly and safely, even on bumpy days, so that you can really get somewhere. You can do something useful with the aircraft. We needed to provide a smooth, aerodynamic, crash-worthy cabin that looked like a flying premium car, and provide vast power reserves and robust handling, so it's easy for inexperienced pilots to handle. And then, of course, people expect the user experience and the user interface to mirror that of all of the user interfaces we see in the modern world. So we needed a digital cockpit, fully connected to the iPad and to the cloud, and a comprehensive autopilot to take all of the workload out of flying a modern light helicopter. And of course, we needed to deliver all of this for the price of a supercar. Now, technically, all of these things have been done before. You mustn't think of HX50 as an all-singing, all-dancing new helicopter. This is very much a greatest hits helicopter, pulling together all the best bits of proven ideas, things that have been done and proven in the field to work, but then doing an amazing job of the packaging and the industrialization of the aircraft to make a great product for general aviation 2.0. The question you then have to ask yourself is, okay, that's what we want, but how do we deliver it? To deliver a high-performance, sophisticated light helicopter, you have to have a turbine engine. There's no other way to do it. But unfortunately, the existing turbine engines on the market at the moment are simply too expensive. By the time you take the OEM cost of a turbine engine, the OEM cost of the suite of avionics, well, that's essentially most of our sale price. So you can't do it that way if you want to be able to sell the product at a price that the market can tolerate. And it's the market that sets the price. The reason we don't sell aircraft in the volumes that we used to isn't because less people want to fly, it's because they're just too expensive at the moment. So What you've got to do then is work out how you go about the business and the engineering of delivering a turbine engine and the avionics and the other elements of HX50 that you need at a price that the market can tolerate. And that's what this program's been all about. We've essentially had to cut out all of the middlemen from the aerospace supply chain and essentially consolidate that margin down to just an honest margin for our company, leaving the sale price of the aircraft at a level that customers can afford to buy. So we had to develop the GT50 engine in-house, again built solely on proven ideas, proven manufacturing processes, proven approaches to all of the known issues and methods for developing a gas turbine engine, and the same for the avionics. Our avionics are not a sophisticated IFR avionics system. They don't have a sophisticated mapping system in there. We don't need any of that. Our avionics are very much the bare minimum that you need for VFR helicopter flight. So we make the basic presentation of the fundamental flight parameters available in the clearest way that you can. We've then fused that with the wonderful technology that's available in the iPad electronic flight book apps, things like ForeFlight, Skydemian, and the tens of other apps that are available out there on the market, and then presented that in a modern digital user interface that's as easy for people to use as driving their car. So essentially what this program has been about is how you define the product that people want to buy and then build an engineering company that can produce all of the parts that you need to at a price that the market sets. And that's what we've done. Clearly, developing a new turbine engine, a new suite of basic avionics, and all of the other stuff that every aircraft needs to do, the structures, the rotor systems, the drivetrains, is a very, very complex and very large engineering task. But there's a number of things that you need to consider. Most profoundly is the fact that we are not developing any of these things from scratch in the same way that the pioneering engineers did back in the 50s, 60s and 70s. We are starting from a point where so much is known about how gas turbine engines work and how you design, optimize, analyze, and then test and qualify these engines, that we're really able to stand on the shoulders of all that knowledge, all of that development, that hard-won knowledge from decades gone by as the start point for our program. We have a much easier job than the people that developed the early engines that we're all flying around in now. The other thing that you need to understand is the level of engineering analysis, simulation, the development tools, and all of the things that we have at our fingertips in 2025 simply didn't exist in the 60s, 70s and 80s when the current stable of gas turbine engines that are used in helicopters were developed. Remember, you're talking about 45 to 65 years ago when these things were developed. Today, we can model and simulate things in 3D. We can use finite element analysis to really probe every detail about the structure, about the heat transfer, about the vibration. We can use computational fluid dynamics to simulate the flow throughout the engine, the combustion process, the fuel spray process, everything you could want to know about these engines we can simulate before we ever build anything. So that then means that we have far less time and far less iteration to do on the test bench when we build these components, on top of the fact that they're already based on solutions that we know work anyway. Frankly, the job that we have to do here in 2025 is much, much easier than it was in the days of the Blue Skies research that led to those first stable of engines. And the other thing you have to be aware of, fundamentally, we are an engineering company. This is what we do all the time. And so we have the skills, we have the knowledge, now we have the facilities to do all of that right here at PC1, and that is what the HX50 program is all about. For a very long time, GA has needed an affordable turbine engine. But to justify the development of a new engine, you really needed a product that was going to sell in sufficient volumes to justify all of that development expense. So what that then means is you need an iconic new product to justify a new engine. And those circumstances in this era of dwindling interest in general aviation were never really believed to be there. For Hill, the timing was just right. We knew that there was this highly frustrated market with large numbers of people that felt that their needs were not being met by the existing suppliers, and there was sufficient pent-up demand that we believed we could sell enough HX50s to justify the development expense of the GT50 engine. And that's exactly what's turned out to be the case. So to develop GT50, we calculated that we needed to sell about 100 helicopters. The rest of it we could support within our own engineering organisation. We've now sold nearly 1,400 helicopters. So GT50 not only has been the catalyst that's allowed us to build a helicopter that has the performance and attributes that everything wants, but the helicopter itself and the demand for it has been what's enabled us to develop the GT50 engine. And that's really what the whole program's been about. Essentially, this is a classic case of, to solve this problem, to reignite interest in general aviation, you had to go big, you had to do it all. You can't do part of this, you can't rely on existing hardware, because you'll deliver a machine with the right performance, but you won't hit a price point that people will buy it at. And we needed to do both to make GA thrive again.